So, good morning, good afternoon, good night, whatever your time zone is you originally have. For me, it's good evening or good night. My name is Nicolai Josuttis. I am the author of a couple of C++ books, and it's all my fault because I was involved in the standardization of C++ for more than 20 years now. So I voted on every standard. The reason I'm coming here is that recently I found a problem. I do most of the time now teach C++ to both beginners and advanced trainings. And also, if you heard the last talk here in the room, I currently teach a big team at an automotive company that implements autonomous driving vehicles. So I learned something about the way we have to teach C++ and the way we have to deal with C++. So let's look. So my first problem starts when I think about what should I teach as a first program and how should it look like? So this is a simple program. Let's include a header file. Let's declare a person. Let's print it up. Already here we have something like 10 different questions regarding style. I mean, we can skip the usual things like naming conventions, spaces, and line breaks. But the first more interesting thing is what should be the suffix of a header file? Should we use namespaces? Which include comes first? Should we use using namespaces or not? When we initialize, should we use braces or parentheses or the equal sign? Where should we declare person to be const? Should we use end line or new line here? Should we have a return 0 statement? That's all the things you have to decide because the beginners, you are the first guy teaching C++. And yeah, we have different answers on these questions in different style guides. And we have more. So let's implement this class person, this type we are using. We have even more questions to answer. So beside of that, an interesting question is, should we first have the private or the public section of this class? Should we have east or west const? I like this discussion. Should the constructors be explicit? Should the output operator be a hidden friend? If you don't know that, wait a minute. Shouldn't the constructor take the argument by value and move it to the member? Shouldn't we overload the getter for two different kinds of references? Shouldn't we use auto somewhere? How much inline should we use, etc.? I've seen all these questions and issues discussed recently. For example, 2 weeks ago, I was at a conference where we had a meetup where we just discussed a short program, and all these questions came up, and we had different opinions in the audience how to deal with that. And then if we make that a base class, yeah, even more questions come into play in addition to the others. Should we declare a virtual destructor? We would usually answer yes, but we not always answer yes, because when I suggested that each and every destructor in a class should automatically be virtual if we have a virtual members, that was rejected. So they are not the opinion that we should always have a virtual destructor. Should we use virtual final, protect the copy constructor here, delete the assignment operator, data member const? Ooh. Yeah, and why do we have that many questions? Well, we have a history. We have a history of C++. This history is even longer than on this slide. We have a history that started way before the first C++ standard in '98, and even then, some questions about style guide came up. The reason is we have so many tricky questions, even in simple programs. There's a good reason for that. One is flexibility. We support many different platforms, many different contexts, etc. Then we grow and grow. We are victims of our own success. So yes, so we become more and more complex. I just checked about the number of pages in the standard we just have for the call language, the basic utilities like pair and smart pointers, and string. So things we would usually say that are essential to use. And we doubled the size of pages just for these features over the past standards. And we are backward compatible. That's still a problem. That's for a good reason again, but we are. We are, in fact, 45 years backward compatible because we are still compatible against C, both in structure and in code and in binary compatibility. And we are community-driven, which changes a couple of things. If you no longer have a chief architect, that means we are 200 people having 200 different opinions and 200 different contexts and 200 different ideas about what is useful for C++. So that's how we got there. So, and we have solved this problem, or we had this problem even with the first C++ standard. So even from the beginning, there were style guides that were introduced. The first style guides introduced were books like Effective C++ and More Effective C++ by Scott Myers. Then there came out a book in 2005, I think, C++ coding standards. And then the talk before, my talk here just introduced them. We developed some style guides, especially for safety, critical environments. Then we established pretty late the C++ core guidelines. And also Google plays now an interesting role. They have published publicly their internal style guides. They have a big, huge C++ code base, which helps us a lot to understand all the issues of C++. And we can double check their new things on a very high code base. So they have their style guides. And I thought, great, we have all these style guides, so let's use them. Unfortunately, these guides are not consistent. So here just some details. As I said, the CPP core guidelines were started in 2015. They are still continuous. We still not have a version 1. The official version currently publishes version 0.8. Here's the link for the Google style guides, app sale tips, which came from the tip of the week. If I understood it correctly, titles, you have to correct me. It was internal project first, and then you went public with that. And here's just an overview of some of the safety critical guidelines. I just learned in the recent talk that there are 15 in the world even. Okay, so, and please note that also these style guides have tool support. Well, the Misra style guides were more or less written by tool vendors who wanted to sell their tools. So they are tool driven, and so they are actual tools you can buy. But we have other tools like the guideline support library, which is an implementation that supports the C++ core guidelines and is integrated and can be integrated in compilers and has an integration in Visual C++. Then we have an interesting thing happened here with the effective C++ style guides. They were becoming an option in GCC, so you could turn them on or some checks against that with W effective C++. It turned out that now people usually recommend not to do so anymore because they are a little bit too strict now. Even the standard don't follow that, or the standard implementations don't follow that. For example, if you have a class person, inside the class person you have declare a vector of int, and then in your constructor you don't initialize a vector. You get a warning saying, well, that should be initialized. But I mean, strictly speaking, you can argue everything is fine because the vector has a specified guaranteed default value. So, by the way, even in GCC, they now say, be aware that the standard library headers do not obey all of these guidelines. So they don't actively promote them anymore. What they promote are other guidelines, -W all. If you double check what guidelines they turn on, here's a list of all of them. It's about 50 different warnings that are enabled with that. And if that's not enough, turn on -W extra. And when I prepared this talk, I went again through these guidelines and was surprised, oh, there's a warning, redundant move. I didn't know that. I don't know whether you know. So yeah, they are cool things. Use them. Okay. So we have different style guides integrated in different tools. So now what's the problem? So, to demonstrate the problem, I want to go through a couple of examples for these style guides. So let's go through just a random or not so random selection of a few style guides and see what happens. And my first example has to be the question, what should be the extension of a header file? Well, there's a nasty history of that. Because when we standardized C++ in 1998, we couldn't agree on a common extension. It all started that Jan's team had a capital H, I think, initially, except when C was involved. And then it turned out capital H and lowercase h can't be distinguished on on Windows operating systems. So they introduced HPP. Other containers used HH or HXX, the X as a slightly well-formed plus plus. So we had that situation, and when we tried to decide about the standard extension for C++ headers, the decision was, as it always is done in politics, we make a compromise. The compromise was no extension at all. Good, which was a nightmare in itself, because now in your file system, look for your header file, your standard header file, and it has no extension. It's hard to find it, and it's hard to create configuration management rules against it. And now I look in the core guidelines and hope they are using what I was using all the times, all the years since then, which is HPP, but they don't do. They recommend still H.H as the extension with saying this is a long-standing convention. Well, it doesn't mean it's good, but that's an argument. Headers are often shared with C. Often is relative, I would say. And it's easier to name all headers in .h instead of having different extensions. I agree with that. But the question is it worth it? Because it turns out that in many, many projects, we run into the same problems, that we can't distinguish C++ header files from other header files. And it starts with having a different syntax highlighting, and if your configuration management has to treat them differently because they somehow deal with them differently than with other header files, you have a significant problem here. So don't follow this guideline. Good. The other thing is initializations. One of our major topics now, because it's one of the first things I have to teach, how to initialize an object. And as we all know, it's a mess now. We started to have a mess, and we made the mess even worse by extending the mess with some uniform initialization approach. And the point is, we want to have now braces everywhere, even without an equal sign, as it was possible in C. So that might have the effect that your normal for loop now looks at like this. Who's writing a for loop like this on the right? Okay, I changed my style 2 years ago, and after 3 months, I felt comfortable. And now it's a smell for me not to have curly braces there. So yeah, we have some history, but the C guys still hate us for that. And yeah, so should we use braces here, or when we initialize base classes? That's the question. And there are arguments in both directions. I agree with that perfectly. So let's look what the style guides say. The core guidelines say prefer the brace initialization syntax. Nobody says take only this syntax, because that's stupid. That doesn't work. But what should you be is your default. So this is a clear recommendation. I would now personally recommend it that way, and we do that in this group of 200 programmers now, and they feel comfortable. Upsell so the Google guys have a different recommendation. It's interesting to read that though uniform is a stretch. It is not uniform, yes, for sure. It's not exactly intuitive. Other programming languages have other syntaxes. I agree. How much should we change our habits? That's an interesting question. It leads to the question as, do we like change or not? And yet, yes, we don't like. That's a problem we have. So there should be good reason to switch to something new. And they don't believe that the benefits outweigh the drawbacks. Okay, so they recommend this one, which I think is a little bit more complicated by default. I don't go into details here. So the point is not to say who is right. The point is that we have different guidelines now. My guideline would be to say we have 3 major options to initialize an int, beside the other 16 ways to initialize an int, which I don't list on this slide. And I would say prefer uniform direct initialization, so using braces, no equal sign, and maybe just the equal sign if it's an easy initialization. And there are a couple of reasons you should do that now. I don't go through this list. There are really a couple of reasons you should do that now. Yeah, good. But we don't agree on that, so how could the SCI guides agree on that? Even in the standard committee, we don't agree on that. I would say that the majority of the 200 guys who standardize C++ doesn't like uniform initialization. Okay, next example, hidden friends. So this should be easier. Because hidden friends, or the topic behind hidden friends, is something we learn, and we all learned sooner or later if we had a good C++ introduction. So you can read it as item 24 in Scott Meyer's book. It says when you have an operator, that is a binary operator, commutative operator, where implicit type conversions make sense on both sides, don't implement it inside the class, because then one of the operands only supports implicit type conversions. Make sure on both sides of the multiplication implicit type conversions are possible. So implement it outside that class as a global function. Okay, there are variations on that. So prefer writing non-member, non-friend functions, or use non-member functions for symmetric operators now in the CPP guideline. The core guidelines, they say, well, similar things, sometimes exactly the right, sometimes slightly different with different flavor. Should it apply to operators or also to more ordinary functions, etc.? So here's a problem we solve. The problem is hopefully well known. If we're, and one flavor is to implement the output operator. Well, there we have no chance. We can't implement a member function because the first operand is an O stream, so we have to implement it outside the class. And that's the way we usually learn to implement the output operator. That's actually the way we implement it in the standard library wherever we implement an output operator. So what's wrong with this? Nothing. It prints. It works. Unless you forget to define it. If you forget to define it, you see an interesting effect. You get an error message. And in this error message, we are listing all the candidates the compiler tries out to find the appropriate operator to print it out. If you just include string, you have 30 different tries here. If you have your code base extended by many classes, that can be significantly longer, and it's not only nasty that the error message is not the best one to understand the problem. And it's scary, in fact, unless you understand how easygoing it is. But that is also a sign of that it takes compile time. The compiler has to find out and check all these candidates against, can I find an implicit type conversion or not? That works. So that's a problem, and that's a problem we see more and more. And that's, by the way, a problem that Google guys see in practice also, as far as I know. And so what can we do? Well, there's another option. The other option is use hidden friends. Hidden friends are friend declarations that are inside the class structure. Who knows hidden friends already? A few. Oh, that's and a half. Okay. So that means you you can say, I implement everything you saw before, but inside the class, but you have to use the keyword friend, because without friend, you're implementing a member function, and that would mean you are implementing the output operator for 3 operands, for a person, for an O-stream, and a person. That's not allowed. So with friend, you say, this is actually a way to implement it inside the class, and the good thing is, by rule, this is used not only for a person, but also for every type derived from person. And that means, but it's otherwise not evaluated. So just in general, a compiler will not look into a class unless the type of the class is involved. So we don't, if we do that, and you add this as a header file, your number of 30 candidates will not raise to 31 for other types. Oh, but then we have AutoSAR. And AutoSAR says, friends shall not be used. There are good reasons for that. I mean, friendship breaks encapsulation, but this friendship definitely not breaks encapsulation. Well, does it break encapsulation or not? Maybe. Why? I say this is my friend, and if you would only declare it here and then implement it outside, you have opened the loop and loophole, and yeah, so there are some issues here. Good. But anyway, they explicitly say this is not compliant to have a friend here in the class. That's the wording they have. By the way, I should say something here. This style guide explicitly says, we have a style guide you should follow, and if you follow it, you have not to explain why you do certain things. It's allowed to break this with an explanation. So, but it's a little bit boring to always explain, yeah, because this is state of the art now, we should use hidden friends. Hidden friends are not discussed in the core guidelines otherwise, so no long distance friendship is part of the last 0.2 versions until we have version 1.0. And please note that hidden friends are important for another reason. This is one of my favorite examples currently. Let's implement the class bigInt. BigInt takes a string because it takes an arbitrary number of digits. Forget that it internally uses long, but that could be one implementation. And then you say, let's implement the multiplication for 2 bigInts. The return value will be in bigInt. Note that we have a constructor taking a string here. So what have we done? We have introduced multiplication for std string. Because there's an implicit type conversion now defined by the constructor, and that will be used. And you were only lucky in other types if you, for example, were using plus or so, that string has its own plus and that has higher priority for the compiler. So you might or might not get a runtime error depending on the value of your string if you multiply 2 strings now. And hidden friends fix this also, because this is not considered to be used if not at any of the operands is a bigInt or derived from bigInt. So that's solved. Okay. How do I know that? Question?
Yes, I have a question. Can you go back to the slide?
Yeah.
Essentially here, I would argue it's a programmer's fault because it makes the operator star, right, available for a qualified loop.
Okay, you say it's an operator's fault. Yeah, I might say, might be, might not be the case. I don't care. I have followed style guides, and I want to see whether this is okay or not. Because we have to face a situation that not each and every C++ programmer understands all the details of C++. That's a problem we have with the complexity of the language. Yeah?
How many style guides would say that the constructor string would be okay with that?
Oh, we come to the question whether this constructor is okay. We come to that question. Yeah. I'm not done. So, first of all, how do I know this hidden friend problem? Problem in feature, I didn't know that at all. We found it when we standardized C++ 17 and got the following bug report. Look at the right side, that's a little bit greater. It turned out that somebody could suddenly take a white string A//B and comparing with an std string SA/B, and the answer was true. Why the hell that? Because we had introduced a type called path. Path had an implicit type conversion from string. We could both convert implicitly to a path, and for a path, it doesn't matter whether you have 1 slash or 2 slashes. So the solution, we fixed that in C++17 as a bug fix. It's not in the standard yet, it will be in C++20 the fix, is that we said this operator for path has to be a hidden friend. Okay, now there's an alternative, and Titus wants to say that. Yes, of course, we all know. Let's use explicit, and we don't have this problem. Good, and that's exactly what, well, some style guides say somewhere. Here, for example, the core style guides say, well, for single argument constructors, we should use explicit, but only by default. Because if you, for example, take this rule, even for a constructor initializing a string from a string literal, you would say, I can no longer directly pass a string literal to a function foo if it takes a string. I have to always explicitly convert it, which can be good or bad. I don't judge this, but that's the effect. And your programmers might not like that if they initialize a vector of string that they have to convert all these string literals to strings instead of pass them directly. So that's the price of using explicit. Then you have to use explicit everywhere. And so some compromise is discussed in C++. It says explicit only in the one argument constructor as it is specified in the core guidelines. That has an interesting side effect. That means, look at this. The declaration in the middle is possible, but the first is valid and the last is valid. If a function foo returns a person, you can't return a string, even not in curly braces. You have to convert it, but you don't have to convert it if you return something that can be converted to a person without a value or with 2 values. That will compile. And the same is true if you initialize a vector of persons. Just the middle thing, having only one argument, will not compile. The other things will compile. So we are getting other issues if we have this rule. And this rule was proposed by paper for the C++20 standard. Here's a link. And we put it out after we voted it in, or after we applied it. And then we found out, no, we have to discuss the design again. And then we took it out again. So, by the way, 2 other things regarding explicit. Note this funny rule that an empty list prefers a default constructor, a non-empty list prefers an initializer list constructor. So if you have mixed explicits in your class, you're getting interesting effects like this. This is an error, this is an error, this is okay, this is okay, this is okay, this is an error. Or okay, depending on how many arguments you have between the curly braces. Yeah, and there's a rule by that, which I don't know whether in any style guide it exists. The default constructor and the initializer list constructor should always be consistent regarding the question whether they are explicit or not, because that's the heart of the problem here. Okay, how do I know that? We made the mistake in C++11 with all the containers, and we fixed that with C++40. So yeah, you see a pattern here. First of all, you might have seen some things you didn't know. Yeah, missing a lack of knowledge, even in the standard committee. And the other thing is we learn over time. We standardized features of C++11 8 years ago, and now finally we have an idea how to use them. And that's another problem we have. Pablo, you asked for an example of Misra. So I should give you one other example of Misra here. And that is the question of enumerations and switch. So there's an interesting upside tip. Use exhaustive switch statements that are defaultless switch statements with responsibility, which is not an easy to understand guideline. It's more or less to say you should know what you do. And there are some constraints when this should be used and when this should be not. The background of this tip is something like this. If you use an enum or enum class, doesn't matter whether it's an enum or enum class, and you have a switch statement, you should switch only over all possible values and not have a default case, default label, because then the compiler will warn, usually or often, if you forget the case. So we have some support here to find out if we extend the statuses by one more status, we should fix the switch statement here. So that's what I usually recommend. Until I went to this group of 200 autonomous driving implementers, and they told me, wait a minute, Nico. You can't give us this guidance. Don't use default here. This is a violation of Misra. Misra says, no. There has to be a default label in a switch statement. Otherwise, it's not a well-formed statement. And remember, the point of Misra is they sell all the tools. So you might say, yeah, I know what I'm doing, but it doesn't go through your tool state, to your quality gate. So, yeah, so we discussed what to do. That's tricky. The best we could come up with was have a default label and there having an assertion, which is still worse because we are Misra conform, but we are turning a compile time warning into a runtime error or compile time error. You can make it a compile time error. Yep.
Isn't that still necessary though? Because there's nothing in C++ that forces an enum, even an enum class, to be one of the values. You can cast an int to establish.
The question is isn't this necessary? Well, the background is, yeah, it might be necessary because in old C, you could have other values than these three, and it's even possible in C++ with enum class, because with using static cast, you can have other values. So shouldn't we have them? Well, that depends on your logic. I only point out that we have tool support to help us not to forget a case label. And we have rules that say, no, this benefit of one tool, the compiler, should be disabled to benefit from another style guide. Yeah, we have contradicting interests in style guides. That's another lesson we learned. And what? There's missing a break. Yeah, that was the trick to find out whether you find it. Oh. Yeah, that's exactly why Misra has this rule, because guys like me make this mistake when they program and add the default label. Yeah. Proof taken, proven. Misra rule proven. Okay. By the way, GCC has 3 different switch options here. They have -W switch, that we lack a case. If there is no default label present, then they have switch enum, that they warn if you lack a case if there's even a default label present. So that's maybe the one you need, but that's not the one that's turned on with -W all. The first one is only enabled, only for enum values. So I think the second one is a better one. And then they have the Misra case just saying you should not forget the default label. Yep, they have support for all the styles. Good. So let me come to my final example. I like that because I have a lot of discussion right now with a couple of guys whether what I tell you now is correct or not. So let's talk about virtual override and final. So in the CPP core guidelines, and a lot of people know that rule, a surprising number of people know that rule and tell me about that, is if you have virtual functions, you should exactly use only one of the keywords virtual override or final, never more. Writing more than one of these is redundant, I understand that, and a potential source of errors. I don't understand that. If somebody knows why, please come to me afterwards or send me an email to explain that. It's simple and clear. Virtual means this is a new virtual function. Override means this is a non-final overrider. Final means this is a final overrider. The background for this rule is if we have something like this, a base class introducing foo and bar, new virtual functions, virtual, fine. Then we have a derived class overriding foo. We should now place foo here so that we see that we don't overload, for example, when we forget the constant. And we can use final here now to say, okay, this is a final overrider, and so nobody else can override this anymore. And if somebody in the derived class can still override foo but not bar, that's an error. That's good because we have marked it fine. So far, so good. I agree. However, there are other applications of these keywords. So a first application of this keyword, which is pretty common, I see that in practice a lot, is, by the way, I should say, it was always possible in the derived class to place virtual or not. This question still remains, and the answer here by the star guide is no, you should not use virtual there. Override and final is enough. As far as I know, there is no semantic difference writing final here again or not. So here's the case I'm missing. In the base class, I have a member function. This member function returns the ID. And I want to make sure that nobody in my full hierarchy can override or hide this function. So it can replace this function by a different code. Because it's key for my whole system that whenever somebody calls getID, I get the ID I computed here, the way I computed it here. It's part of my framework that this works right. The problem is they can't. Without being a virtual function, you can add a new implementation of getID, which is formally not overriding, which is formally hiding. But the effect is similar. It means that if you have a B and you call getID, you get a change implementation of getID. So how can I prevent that? Well, of course, we have final. Great, so add final here. Unfortunately, we can't add final here because final needs virtual functions. So I have to add virtual here also. And then this is solve this problem. So the rule saying you should exactly use only one of virtual, override, or final is broken by this requirement. So we at least have one exception here. And yeah. By the way, for those who are getting worried now and say, wait a minute, virtual, isn't that making things bad because we now need a runtime decision and a vtable for this? No, that's not true. If you're on top of a hierarchy, then this is not in the vtable because the compiler knows that there can't be any other implementation of this. So virtual final will still be used as an inline function and will be optimized as an inline function. So that's the way you can do that. So, and therefore, I have a problem with that rule. And we have applications like this even in the standard. In the standard, we have here in the locales, we have this topic implemented. We have here true name and false name. They call the virtual function do true name and true false name. And the intention is that nobody overrides true name and false name here, just implements new ways to return a true or false value by re-implementing do true name and do false name. So an interesting question is, shouldn't this all be based, the non-do member functions here, shouldn't they all become virtual final? Nobody proposed that yet, as far as I know, but that's a question, and that's a case where we have this requirement in the library. So I have another rule. And the other rule is interesting, totally different. My rule is either everything is virtual or nothing is virtual, except where it can. So not in constructor, static function friends, but everywhere else you always write virtual if this is a polymorphic type. type, and otherwise not. That's a more simple rule to teach, I think. And if somebody has a problem because they don't want to have virtuality, because they want to have it inline, so they mark it with final, and they have the effect. Everything is nicely aligned. I'm not sure whether this is a good rule. No, James is shaking his head. Oh my goodness. So we have to talk about that.
You should have just asked me and I told you it's terrible.
Ah, it's terrible. Okay, James says this is terrible. Good. I would like to learn it why. But I mean, that's my point here. My point here is we have different contexts, different experiences. We have different rules following from that. And then, yeah, we should discuss. A couple of hands now. Oh my goodness. Timur. As far as I know, this is not a warning. It's a warning now? Okay. Good. Fine. It's okay. So I don't see why this is a problem then to allow that. This way, to say virtual final. Then I don't have a warning. Then I can be sure that this is not overwritten or hidden. So you ask me, I don't trust those who derive from my class? Yes. There are contexts where I have to trust them, and there are contexts where I have a problem when I don't trust them. Yes, I agree. In general, we have a problem if we can't trust. There are other ways that derived classes that then screw up my base classes. Yes, I agree on that. Yeah, but this is just one example. I think, Alistair, you had? Okay.
Yes. You were asking the people who don't know why virtual final is bad. But virtual final in bar is bad for the same reason it's good in get ID. That there's no, it's not checking that it's actually overriding the virtual function. You could have been a typo.
Yeah, that's the argument. The argument is, if I write in B virtual final and not only final, I don't see that I'm overriding. But my recommendation then would be to say, I have to declare it virtual final override, because that's my intention here. I want to override a base function. That should be the way you do it, because with override you say it's my intention to override a function in the base. So yeah, we have things to discuss here. I think we agree on that. Or you think this guy has no idea, no clue. Yeah, also right, probably. I'm probably beyond the average programmer who has similar questions and doesn't know the answers or some answers. So let's come to the style guides. And yeah, at least my problem would be, my case, having in the base slice a function that is final is not solved. Good. Just as a bonus here, just to give you some examples, also that what we have, we have overlaps in the style guides, but we also in the style guides, each style guide has its own rules. So if we combine and merge all these style guides, we get a huge repository probably of different rules. I didn't find this anywhere else, but I might be wrong. So this is again an AppStyle tip saying, should you prefer pushback or placeback? And the answer is you should push back if that's enough. Don't use too much, because it might introduce more danger. With placeback, you never know whether this is directly taking this value to initialize, to say this is my new value. Or for example, if in placeback here, the vector 2 is a vector of vectors, you might use this as a size of a vector in this vector and insert a vector of, 1 million elements here. That danger you don't have if you use here back1 and just think you are inserting an int all along. Good. My message is this. Enough of examples. We have a mess of C++ features for good reasons. for a reason we understand, history, etc. The only way to get out of this mess, except that we all become huge and great C++ programmers understanding all the corner cases. Remember how many issues I already raised with my first example, is we need style guides. I think style guides are a solution to tame the beast here. And give us, they don't have to give us guidance that we follow all the time. Might be enough to say this is by default what we should do, and maybe just to make it consistent what we teach in beginner classes, and not that everybody teaches something different. We have a mess of style guides. That's a problem, so we need them, but we have a mess there because C++ changed over time. We have different opinions, what is right. We have different contexts and where we use C++. We have different goals, what we want to do with C++. We have that because we don't like change. We don't know better yet. We have legacy tools that don't support the new ways. And because cleaning this up, all the style guide needs time and work. Remember that the core guidelines still are at version 0.8, and the number of updates has going down. I understand that. That's not to complain. The problem is, yes, it's a huge task to tame the beast. Yeah, and we have the problem of that per se. We have different goals like performance, where there's maintainability, safety, where there's portability, whatsoever. We have history and context. So that we can't solve. So what should we teach? How would I answer all these? I think it's something like 20 different questions about this class. Can we agree here on one way we teach to beginners? Is that possible or not? When I discussed this with a couple of guys, also in the standard committee, they said, no, we don't have to agree on that. The question is not, what should we teach? The question is might only be, when should we teach what? Because sooner or later, you have to know all the rules that are key for your context. And maybe it doesn't matter which order you teach things, as long as you sooner or later teach everything you need to know. Okay? There are multiple paths to become a good C++ programmer. Maybe we just have to accept that. Okay, but then at least we have to say that when we teach C++ to beginners. And we can also argue that different style guides is good. We both had that discussion yesterday over, not a beer, over what you were playing some strange game there on the table. It's I'm talking to Titus Winters, who is chair of the library working group at Google for app sales. So yeah, I asked him about this, and he said, "Well, having different style guides is good." Yeah, because we have different contexts, and other people say maybe we should at least follow the way we standardize. So the way we standardize is a good criterion to get an idea of what is okay. So we finally found out that hidden friends are better than not hidden friends, so let's use them. Well, but we still declare templates with class. Oh my goodness. So this is not a thing you should learn. The C++ standard is not a style guide. End of discussion. Which would not be a problem if not so many people would quote from that. Yeah? So here, the declaration of class vector still uses class for the template parameters. And therefore, CppReference.com, nobody looks in the standard, but they all look at CppReference.com. And then they see, oh, vector, oh, wait a minute, the arguments are class, why that? I learned it's type name. Okay. Yeah, so maybe we should at least clean that up. Because to some extent, the standard is a style guide. against its own will. So what should we do? Let's end up. I have no solution. This is a talk to raise the problem, to raise awareness of this problem, and maybe we get some ideas or think about it. I have no solution. I have some ideas. No, not even ideas. I have some questions to you, and maybe we just raise hands over different options we have. So let's go through a couple of options. That's life. Leave it as it is. It's obviously one option. Require at least that when we propose new C++ feature, that we finally require that for each and every C++ feature, there is a few examples or a table saying what is the difference between what was the situation before and after. Or in other words, what is the effect for style guides of this new feature? This is not required. It happens very often that we don't understand why we standardize something, at least looking back 10 years later. Yeah, that's a problem. Even in the committee, we have problems to understand all our rules. And by the way, sometimes this is good, because sometimes we have different understanding what this means, and therefore we vote it in. And it turned out to be good. But would we have known what we have voted in its full complexity, then we wouldn't have voted it in. So one example is namespace, and one other example is templates in their meta programming fashion. Establish an official style guide as part of the standardization. That's the third option. Unretire Scott Myers to write a new guidance book. Or we find another guy, Style Guru. Improve the standard step by step. Replace, for example, class by type name. And I just learned it in the talk before. Concentrate at least on safety critical aspects. Let's take some votes here. What do you think? Who is in favor of option A? Three. Who is in favor of option B? That's close to half, no? Third to half. Establish an official style guide. A few? Okay.
You can make an official style.
And retire Scott Myers or, okay. Improve the standard step by step to be more style guide conforming. Okay. Also, half. Concentrate at least on the safety critical aspects. Okay. Less than half. Okay. So we have a path. There's a question.
Be there. Could you change require to provide potentially later?
Could I change require to provide is the question. Provide.
You may not know going in, as you said, everything
No,
involved.
I think we already have provide. So we don't are against papers that explain why they want to have the new feature. The question is, should we now require it because it didn't work?
I think I'm saying require it, but in time. Like maybe.
Require it in time.
But if you don't actually know going in all the components, which has happened, providing it.
Okay, so you say in case, so before the last vote, there should be an explanation why we want to have it. That should be the last time we should have this requirement. It might not be in the first time we present the update because we never know what is accepted by the standard.
I'm talking more of an iterative process.
Iterative process, yeah.
You might approve it and then later realize
Yeah, but
there's more to it.
But why can't an iterative process don't start at the beginning with also having these effect clauses and then iterate through them? Yeah. Okay. That's it. That's all I have to say here. Again, no solution, just a complaint. And I will talk to James why my idea with everything volatile or not is not a good idea. Thank you very much for your attention.